my lovely viewers, welcome again to Mathematics and I. It is a presenter, Jeff Lionel, and today we shall be looking at integrating trigonometry functions involving limits and without limits. Okay, now involving trigonometry functions involving limits and without limits. Now don't forget we said in our previous videos on integration, we said that integrals without limits are called indefinite integrals, and the integrals with limits are called definite integrals. So we have two questions on the board, and we shall see how we can solve this problem. Now, if you know this is your first time of joining us in our channel, please don't forget to subscribe and don't forget to share our videos. Okay, let us begin the class. Question number 1 says, integrate sine 10x dx. Okay, integrate sine 10x dx. Now, how do you solve a problem like this? Now, we will solve this problem using chain rule. Now, we know that chain rule is under differentiation, but this is how we can solve this problem. Now, in chain rule, we said chain rule has just one function, and that the name of the function is u. Now, in this question, the function that we have here is 10x. So, it means u is equal to 10x. Now, at this point, we will differentiate u with respect to x. So, du over dx becomes 10, because if we should differentiate 10x, we will get 10. Now, if we should find the derivative of u with respect to x, the next thing we are going to do here is to make ds the subject of the formula. And how can I make ds the subject of the formula? By cross multiplying. Okay, now if we should cross multiply, 10 times dx gives us 10 dx, okay, and du times 1 gives us du. Now, our aim again is to make ds the subject of the formula. Now, for us to make ds the subject of the formula, it means we need to make sure ds stands alone. And now, at this point, 10 is actually making the x not to be the subject. So, what do I have to do? I will divide both sides by 10. Okay, now if 10 should cancel out 10, you see we have the x left, and our dx becomes du over 10. Now, once we get our ds as the subject of the formula, the next thing that we are going to do now is to come back to the original question and rewrite the question. Now, when we are rewriting the question now, we will be substituting for anywhere we see 10x and the x, we will substitute their new word function. Now, let us begin. Now, rewriting the question. Now, this is sine, and this is 10x. Now, don't forget we just said that 10x is u. So, instead of me writing sine 10x, I would write sine u. Dot. Okay. Now, what do we have here? dx. Now, instead of me writing dx, now what would I write? du over 10. Okay. Now, at this point, we will now integrate sine u. Now, if we integrate sine u, we are going to get minus cos u over 10 plus k. Now, why is k added? Because the question is an indefinite integral. And whenever you integrate an indefinite integral, your constant is added. So now, don't forget we said that u is 10x. So automatically here becomes minus cos 10x all over 10 plus k. So this is the answer we would get if we integrate the function sin 10x dx. Now, question number 1 has been solved. Let us attempt question number 2. But before we attempt question number 2, don't forget to subscribe if this is the first time of joining our page, and also don't forget to share our videos so that others can also learn from it. Now, question number 2 takes a different look, because why? Question number 2 has limits. Now, the upper limit here we have pi over 2, and then on the lower limit here we have pi over 4. Now, don't forget that pi in angles means 180 degrees. So, how can we solve this problem? Let us begin. Question number 2. Okay, question number 2 says integrate. We have pi over 2, we have pi over 4, and then we have cos x dx. Now, what we are going to do now is this. In place of pi, we would put 180 degree in place of pi. So now, if pi is 180 degree, this is what we are going to get. The integral 180 over 2, and then we have cos, okay, we have cos x dx, and then we are going to be having 180 over 4. Now, 180 over 2 is 90, and then we have cos x dx, and 180 over 4 is 45. Okay, now at this point, we are going to be having something like this. Now that we have solved the limits, let us integrate now. Now, if we should integrate cos x, we are going to get this. Now, if we integrate cos x, we are going to get sin x. So automatically, here becomes 90, 45. And if we integrate cos x, I will get sin x. Now, at this point, this is what we are going to do. We are going to substitute the values for 90 and 45 for x in the function. So we are going to say when x is 90. Okay, now when x is 90, we are going to say sine 90. Now, sine 90 is equal to what? 1. So that's the value when we use the upper limit 90. And the next one I'm going to say is when x is 45. Okay, now it means anywhere I see x, I would write sine 45. Now, sine 45 is root 2 over 2. Now, when we get the answers for the upper and the lower limits, this is what we're going to do. We are going to subtract the values. So if we should subtract the first answer, which is 1, minus the second answer, which is root 2 over 2, this is what we are going to get. Now we're going to base 1 over 1 and look for the LCM. Now the LCM is 2. Now 1 will go into 2 times. 2 times 1 gives us 2 minus 2 into 2 is 1. 1 times root 2 it gives us root 2. Now 2 minus root 2 over 2 becomes the answer if we should integrate the definite integral pi over 2 cos x dx and what? Pi over 4. So this is how you can solve problems under integrating integrals that are definite and integrals that are indefinite in trigonometry functions. So we have come to the end of today's class. If this is the first time joining us, please don't forget to subscribe to our channel, and also don't forget to share our videos. And don't forget we also offer online classes. So for those of you that are available or that need online classes in mathematics, please tweet us on Twitter at Jeff9, and then we shall get back to you. Till we meet again in our next class, always remember to study. Bye for now.